In earlier video, we have seen the theorem 6 and 7, and we have understand what we have proved in the theorem 6 and what we have proved in the theorem 7. Now let's see its related problems and solutions of theorem 6 and 7. So let's start our geometry session, and this video is for the problems and solutions of theorem 6 and 7. So before I go into the problems, so just I want to say you, please watch my video related theorem 6 and 7, then you try to solve all these problems and see the solution, so that easily understand and you can build up your concept about the theorem 6 and theorem 7. Now let's see our first problem. So this problem is said that show that the straight line which joins the vertex of an isosceles triangle to the middle point of the base. Now you see. So first I have drawn the isosceles triangle. So any problems of the related to the theorem. So first we have to draw the diagram. So this is our triangle ABC and this is the line AD. So this line is the middle point of the base. So this is the important. So this is the middle point of the base. So that this D point is the middle point of the base. So what we have to prove? So we have to prove that this AD line is the bisect of this vertical angle. Vertical angle means this BAC angle. Bisect means these two angles, this ABD angle equals to this CAD angle. And the next problem is this line, this AD line is the perpendicular with the base, means this ADB angle equals to this CDA angle. So that we can prove that this AD line is the vertical with the base, means the BC line. So let's see the solution. So the solution is the first solution, the bisects the vertical line. So again you have seen here these two triangles have been formed. This two triangle is the ABD triangle and another triangle is the ACD triangle. And if we prove these two triangles are equal in all respect, then these all problems will be solved in very easily. So how we will prove that these two triangles are equal? So first you have seen this is the isosceles triangle. So this AB equals to AC. And this D point is the middle point. So this BD line equals to DC line. Okay. And this AD is the common for this both two triangles. So these two triangles, three sides are equal. Okay. So we can easily say these triangles are equal in all respect. Means its three sides are equal, you have proved, and it is also its three angles equals its corresponding three angles of another triangle. Okay. Now we can say this BAD, this BAD angle is equals with this CAD angle. So if these two angles are equal, then we can say this AD line is the bisect of this vertex angle, means this BAC angle, this whole angle. So comes to our next problem. So this next problem is this is a triangle, and this triangles, this AD line is the perpendicular with this BC line. This line is the perpendicular. So how we'll prove that? So again, earlier we have proved that this ABD triangle and this ACD triangles are equal in all respect. So this angle, so ADB angle is equals to its corresponding angle CD. Okay. Now, if these two angles are equal, this is a straight line BC. So BC straight line's angle equals to 180 degree. So this point is very much important. So that this AD line is the perpendicular with this BC line. So just you use your concept and your mind and related to this theorem 6 and 7, then you can easily solve all these problems. So you don't require to remind or memorize any solutions of any problems. Just you use your brain and concept. Now let's see the second problem. Now this second problem is said if ABCD is a rhombus, that is an equilateral four-sided figure, so that diagonal this the angle ABC equals to angle ADC, and AC bisects each of the angles BAD and BCD. Okay. First this is the diagonal AC. Okay. Its diagonal is the AC. So first we have to prove that this ABC angle, this angle is equals to ADC angle. Now it is very easy to prove, just you require to use your concept. So this is a rhombus and this is a equilateral four-sided, means this AB equals to BC equals to CD equals to AD. So now you see here, if we see these two triangles ABC, this triangle, and ADC, this triangle. So we have to prove these two triangles are equal in all respect. Okay, if I prove that, then we can say these two angles, this ABC angle equals to this ADC angle. So how we'll prove that? So this AB equals to AD, or this DC, because this all sides are equal, and this BC equals to AD, and this AC line is the common for this both triangle. Okay. So this triangle ABC and ADC equal in all respect. If it is equal in all respect, then we can say this ABC angle is corresponding angle ADC. Now see our next problem. So this angle BAD, this total angle BAD equals to angle BCD. Okay. Now we know that this ABC and ADC, these two triangles, equal in all respect. Earlier we have seen the proof. Then we can say this ABC, this BAC, this angle, this BAC angle, this BAC angle equals to this DAC angle. Okay, this is BAC angle equals to DAC angle. And again, this corresponding to angle, this ACB angle equals to this DCA angle or ACD angle, this one. So if these two angles are equal with each other, then we can say this line, this AC line is the bisect of this whole angle, this BAD angle, and this whole angle DCB angle or BCD angles bisect. Okay. So this is also very simple problem, but we use our concept. Now come to the problem 3. And this problem is said, if an this quadrilateral ABCD, okay, and the opposite sides are equal. This quadrilaterals is a quadrilateral, this ABCD, and its opposite sides is equal. This namely AB equals to CD and AD equals to CB. Already told and prove that is the angle ADC equals to angle ABC. So first we have to draw the diagram. So already said this AB line equals to this CD line and this AD line equals to this BC line and AC is the diagonal. So this ADC angle, this angle is equals to this angle ABC angle. So actually I have drawn this diagonal AC. Just we have joined these 2 points A and C. Then this is called the diagonal. AC is the diagonal. Then this line have been formed the 2 triangle. This one triangle is the ABC triangle and another triangle is the ADC triangle. So if we prove these 2 triangles are equal in all respect, then we can easily prove that these 2 angles are equal. Means we know this AB line equals to this DC line and BC line equals to AB line, and these lines are common for this both triangle. So we can say this ABC triangle equals to this ADC triangle in all respect. Means all 3 angles are equal with this corresponding another triangles all. Okay. So we can say very easily that this ABC angle equals to this is DC angle. Now let's come our problem 4. This all problems are related to the problem theorem 6 and 7. So this is my request. If you want to solutions, first you watch the theorem 6 and 7 and gather some concept. Then you solve all these problems. Then your all concept will be clear. Okay. Now this ABC and DBC, this ABC and DBC are 2 isosceles triangle. Isosceles triangle means its 2 sides are equal, drawn on opposite sides of the same base BC. And if AD joined, then prove that each of the angles BAC and BDC will be divided into 2 equal parts. Okay. So first you draw the diagram. So this is the diagram. So this is the ABC triangle and another is the BDC triangle. And this 2 point A and this D, it is the opposite sides. This is the opposite sides. And what happened then? We join this AD point by this line. This is the AD line. Then we have to prove this. What we have to prove? This BAC. this BAC and BAC, this total angle, and this BDC, this total angle is divided by two equal part by this AD line, by this line. Okay. So how we will prove that? So now you see these two triangles have been formed here. This one triangle is the ABD triangle, and another triangle is the ACD triangle. Okay. Now let's see. So these two triangles, this BAD, these two triangles have been formed. Another triangle is the ACD or DAC triangle. And this ABC is the isosceles triangle. So its two sides AB equals to AC. And this BDC also an isosceles triangle. So this BD equals to CD. And this AD line, this line is the common for this both triangle. So you can say these two triangles ABD and ACD are equal in all respect. So these two angles, this BAD, this angle is equals to this angle, and this angle, this BDA angle equals to this CD angle. Okay. Now you can say this AD line, this line is bisect this BAC angle and BDC. Okay. So now let's see our next problem. So this is the problem 5. First I am saying you, if these triangles, three sides are equal in with this another triangle, then these two triangles are equal in all respect. If you don't understand these things, so please watch my another video which is related to the concept of theorem 4. Then you can easily understand so how two triangles are equals in all respect. So if ABC DBC are two isosceles triangle drawn on the same base BC, so prove that this angle ABD equals to angle ACD. And the case where the triangle are on the same side of BC, the case where they are opposite sides of BC. So there is a two cases there. One is the opposite sides of two triangle, another is the same sides of the two triangle. Now let's see the first problem. So this is the ABC triangle and this is the same side. This is a BDC is the same side. So this is the triangle, this BDC, and this is the another triangle ABC. So first we have to prove that this ABD, this angle equals to this ACD angle. So how we will prove that? Earlier problems in solutions of theorem 5, some problems and solution of theorem 5, I have proved that problem, but here I want to prove these problems in different way. So by theorem 6 and 7, I want to prove these problems. So now you see here, this is a two triangle. So this BAD triangle, another is the CAD triangle. BAD triangle and CAD triangle. Okay. Now, let's see the proof. So it's AB equals to AC. because this is an isoscale triangle. ABC is the isoscale triangle, and BD equals to DC. It is also isoscale triangle, and this AD is the common for both. This AD is common for both. So now you can say these two triangles are equal in all respect. In all respect. So this is very important. If this equal in all respect means all three sides and three angles are equal with the another triangle corresponding another triangles, three sides and three angles. So we can easily say, so this angle, this ABD angle equals to this ACD angle. Okay. Now let's see another problem, and this is the two triangle is here and these are opposite sides. So this A and D point is the opposite sides. And again we have to prove that this ABD, this total angle equals to this ACD. How we'll prove that? So again is a simple, we have proved it is earlier also. This two triangle has been formed. These two triangle have been formed. So this AB equals to AC because it is an isoscale triangle, and BD equals to this because it is also an isoscale triangle. And this AD line is the common for this both triangle. So this ABD angle ABD equals to its corresponding angle ACD. Okay. Now let's see our next problem. This is the problem 6. This problem 6 is said that show that the straight lines which join the extremities of the base of an isosceles triangle to the middle points of the opposite sides are equal to one another. First, you see the word of these problems. They show that the straight lines which join the extremities of the base of an isoscale triangles to the middle points of the opposite sides are equal to one another. So this is a point C. Okay. And you see here the straight lines which join the extremities of the base of the isoscale triangle. So this is a AB is the line and its extremities base point is the C. So I have joined this CD line and this D is the middle point. And the same is the B is the point and this extremities line or this point middle point is the E. So this is the AC line and its middle point is the E. So these two lines should be equal. So this CD equals to B. Okay. So now you see here, these two triangle have been formed. This triangle BCD and triangle BCE. If we prove these two triangles are equal in all respect, then we can prove easily that these two lines are equal. Okay. So we have to prove that this BE equals to DC. Now you see, this is an isoscale triangle. So this ABC angle equals to ACB angle. Okay. So this ABC angle equals to angle ACB angle. So we can say this angle DBC equals to angle DCB angle. And it's the D is the middle point. So this AB equals to AC. AB equals to AC. So equals to or equals to half of AB equals to half of AC. So equals to what happened? Or this DB equals to EC. Okay. This DB equals to EC. This is. And this BC is the common for BC common for both triangle. Common for both triangle. So this triangle BCD and BCE is equal in all respect. So these two triangles, this BCD triangle, this BCD triangle is equals to this EBC triangle. So we can easily say this DC line equals to BE line. So this DC line equals to BE line. So this next problem, this problem 7, these two given points in the base of an isosceles triangles are equidistant from the extremities of the base. Extremities of the base means the 2 points of the base. So that they are equidistant from the vertex. Vertex means the top point. So first we have to draw the diagram. So this is a ABC triangle and equidistant from B to D and E to C, and these two are equal. So this already said BD equals to EC. So now you see here, we have to prove that these two triangle, this ABD triangle equals to AEC triangle. So if we prove that these two triangle ABD triangle equals to AEC triangle, then we can easily prove that these two lines AD line equals to AE line. So how we'll prove that? So first this BD equals to EC, and it is also the isosceles triangle. So this AB line equals to AC line. So AB equals to AC. And again, this is isosceles triangle. So these two angles, ABD or ABC angle equals to ACB angle. So this angle ABD equals to angle ACE angle. So these two sides are equal and one angle is equal for this both triangle. So we can say these two triangles, this ABD triangle equals to this triangle AEAC triangle or AEC triangle. So this is in all respect. So we can easily say this AD equals to AD. So these all are equidistant from the vertex. So this is our solution. Now come to the problem 8. So this problem is said that so that the triangle formed by joining the middle points of the side of an equilateral triangle is also equilateral. So this is not an isosceles triangle, this is an equilateral triangle. So equilateral triangle means its all three sides are equal. So we have to prove that this equilateral triangle's middle point, so we have joined these three middle points of this equilateral triangle, then it is also formed a equilateral triangle like this way. Oh, sorry, this should be B and this should be C and this should be E and this should be EF and this should be G. Okay. Now you see here. So this is the equilateral triangle, means it's all three sides. AB equals to BC equals to AC. Means AB equals to BC equals to AC. Okay. So first we want to prove this one. So also this is an equilateral triangle. Also these three angles. Angle ABC equals to angle BCA equals to angle BAC. All three angles are equal. So if we see this two triangle, this triangle EBA and this triangle CFG. Okay. Now you see here this two angle, this angle EBF equals to angle FCG. Again, these two lines, this line equals to this line equals to, because this is a middle point. So it's BF equals to FC and BE equals to CG. Now you can say these two triangles are equal in all respect. So these two triangles EBF equals to triangle CFG. So we can say easily this EF equals to FG. So by same way, we can prove that this FG equals to EG. Also by same way, we can prove B FG FE FE equals to EG. So now you see here all sides are equal. So this EF equals to EG equals to GA. So now you say these three sides are equal. So this triangle, this triangle, this triangle EFG is equilateral. Equilateral triangle. This is good. Now come to the problem 9. So this problem is said this is ABC is an isosceles triangle, means its two sides are equal. This AB equals to AC. And the angle at B and C are bisect by BO and CO. So that BO equals to CO and AO bisect the angle BS. So this angle, this two angle, this ABC angle bisect the BO and this ACB angle bisect the CO. So now we have to prove this BO equals to CO. So here two triangle has been formed here, this AOB and another triangle is the AOC. How it is formed? Because I have joined these 2 points, this A and O. This is I have drawn. So I have drawn here, I have joined this A with this point A to point O. this line. So this two triangle has been formed. This triangle is the AOB and another triangle is the AOC. So if we see here, these two triangles, AB equals to AC. Okay. And solve this problem to be solved in different way. We can solve this problem in two way. So one is the we can solve in very easy way. So this is a bisect. So this angle and this angle should be equal because these two angles are equal. ABC angle equals to this ACB angle. This angle ABC angle equals to angle ACB angle. And is a bisect by this point O, this BO and CO. So this half of angle ABC equals to half of angle ACB. So means this OBC angle equals to angle OCB. So if these two angles are equal, then we can say this BO equals to CO. So we can say easily because it is an isosceles triangle. So this BOC triangle equals to isosceles. So we can easily say this BO equals to OC. And AO bisect the angle BAC. So now you see, now comes to the point. So this line, this AO line is bisect this BAC angle, means this BAO angle. So this angle is equals to this angle. Now you see here, this triangle AOB and this triangle AOC. So this AB equals to AC. Already said this is an isosceles triangle, and already we have proved that this BO equals to OC, or this is a half of. Also, we can prove by this way also. This is a half of angle ABC equals to half of angle ACB, means this ABO angle ABO equals to angle ACO. Now we can say easily, and this AO line is the both for AO line is the common. So now we can say this triangle AOB equals to this triangle AOC. So now we can say this angle BAO equals to angle OAC. Okay. So now we can say this AO line is the bisect of this angle BAC. Okay. So this one. Also by this way we can also say this BO equals to OC. So it is not required. So we can again by this way we can say this BO equals to OC. So we can prove this first problem by this way or by this. Okay. So let's come for our second problem. Second problem 10. So this problem is show that the diagonal of rhombus bisect one another at right angle. So this rhombus means its all sides are equal. Now you say here it's this all angles are equal. So if we prove this all angles are equal, then we can say this this is the right angle. All angles are right angle because this total angle is the 360 degree. 360 degree. Yeah, and all angles are equal means by 4 equals to 90 degree. So how we will prove that? Now you see here. Now you prove this problem by your own. Then please comment me. Then I will show how you prove this problem. So this is your task to prove this problem. This is a problem number 11. This is also a very simple problem, and this is I have not given some marking. So this is a ABC triangle. So again this is a ABC triangle, and this BA equals to CA. So this BA equals to CA, and this is the angle BAC are produced beyond the vertex A. Angle BAC beyond the vertex A, and this is the E point. This is the E point and F point. This is the F and this is the E. And I have joined this AB and EC are joined. Then we have to prove that this FB equals to EC. Means we have to prove that this triangle BFA equals to this triangle CEA. And this is this E and A produced of beyond this BAC and beyond the vertex A the points E and F, and so that AE is equal to AF. Means already said is AE equals to AF. So this AE equals to AF. Okay. So now you can easily prove that these two triangles are equal in all respect. So this angle is equal with this angle because this angle is the count. This angle is equals to this angle, right? This vertically opposite angle. Now I have told you how we will prove this, but you prove in your own, and please give some comment. Then if you don't understand, then I can say you how you will prove these problems. Thank you.